In this video, you'll learn why PHP frameworks like Laravel and Symfony use an Object Relational Mapper, or ORM, to deal with data in a database. This simplifies working with a database by mapping tables to objects, reducing manual SQL, and improving maintainability. So far in this series, we've developed code to easily render templates from controllers. These templates only contain basic content though. Let's see how we display data from a database in here. I've already got a database called shopdb created in my local database server. This contains a table called product that contains 3 records. There's an SQL script that will create this database and its data in the repository for this series, and there's a link in the description. In a plain PHP application, you might mix the code that retrieves data from the database with the presentation code where it's displayed. In a framework like this, however, a template just contains the minimum code to display data that's passed to it. So instead, let's get the data inside the product controller's index method. First, let's use plain PHP. I'll just write the absolute minimum code we need to connect to the database using PDO, then select all the records from the product table. Normally you'd include some code in here to check that the connection worked and so on, but for the purposes of this example, I'll keep it simple. I'll set the fetch mode to return an object for each row. So we can use the PDO class like this, we need to include a use statement for that class. For now, let's just output the contents of the products variable and exit the script. Note that you would typically write code like this in a separate class and not in the controller method directly, but this is just to see how this works in plain PHP, as later on we'll do this using a third-party ORM package. Let's have a look at the products index page in the browser, and we see the data from the database. Each row has been returned as an object of the PHP standard class. Instead of printing this out like this, let's pass it to the view when we render it. Then, in the index template, let's add some HTML to display this data in a table. In the table body, let's loop around the product variable and escape the name and the description. We don't need to escape the size as it's an integer. Now when we view this in the browser, we get the data displayed in a table. Instead of retrieving each record as a PHP standard class object, we can tell PDO to use a specific class. This is what Object Relational Mappers do. You can think of each table as a class, and each record as an object of that class. Some frameworks refer to these classes as models, some as entities. I prefer entities, so let's create a folder in the source folder called entities, and inside that folder, a file called product.php. In here, let's add the corresponding class definition. As an object of this class will represent a product record, let's add properties that correspond to the columns of the product table. You could make these public, but I prefer to make them private and have getter and setter methods for each one. I'll omit the setter for the ID, as that is a value that's assigned automatically by the database when we create a new record. We don't need to add any more functionality to this class, as it's only used to represent records from the database. Then, in the controller, let's set the PDO fetch mode to fetch class and specify the product entity class. Let's also add the use statement for that class. Then in the index view, let's use the getter methods to access the property values. When we run that, we get the same output as before. So this is a simple example of how we can retrieve data from the database, mapping records to objects. This is one of the things an ORM does, such as Eloquent in Laravel or Doctrine in Symfony. However, an ORM does a lot more. With this code, we have to explicitly connect to the database and write the SQL to perform the query we want. And ORM reduces or even removes the need to do this, providing us with built-in methods for common tasks like retrieving all records, retrieving an individual one based on a key value, and so on. Rather than build an ORM from scratch, let's add an existing one to the framework. One of the most popular is Doctrine, which is what I'm going to choose. It's also what Symfony uses. So, on the command line, from the root of our project, let's use Composer to install the Doctrine ORM package. In the Products controller, let's replace this PDO code with the equivalent Doctrine code. To use Doctrine, first we need to tell it where to find the entity classes. Let's do this by creating an array variable that contains the paths to these classes, which in our case is the source entities folder. We then create a configuration object using the createAttributeMetadata configuration method on the ORM setup class, passing in these paths. For now, let's also pass in true as the second argument to this, which enables development mode. And to use this class like this, we need a corresponding use statement. Then, let's create an array containing the connection parameters. These are the same as the ones we used for the PDO connection, with an additional parameter called driver, which is set to PDO MySQL. If you're using a different database server, then you'd put a different value in here. There's a list of available drivers in the official documentation. Note that we wouldn't typically store database connection credentials in here like this, but we'll look at best practices for configuration settings in a later video. Then we can use the Driver Manager class to get a connection to the database, passing in these parameters and the configuration object. And this also requires a use statement. Once we have the connection, we can create an instance of the Entity Manager class, passing in the connection and the configuration objects. And this of course requires a use statement. The Doctrine Entity Manager is the central service that manages all entities. Next, we can get a repository object from the Entity Manager for the Product Entity class. A repository object is the class responsible for fetching entities from the database. These provide various methods for retrieving records from the database as entity objects. For example, to get all records, we use the findAll method. Let's try running that, and we get an error. Doctrine needs a cache implementation to work, and recommends the Symfony cache package. So, on the command line, let's install that with Composer. Let's run that again, and now we get a different error. The product entity class is not a valid entity. So that Doctrine can recognize this product class as an entity class, we need to add some attributes to it. First, let's import the Doctrine ORM mapping class with an alias of ORM. Then we can add attributes that tell Doctrine that this is an entity, and that the table name in the database is product. We also need to add attributes before each property, telling Doctrine that the property should map to a column, and what data type it is. Let's run that again, and now we get another error. There's no identifier or primary key specified. In the database table, the ID column is the primary key, so let's add the ID attribute to this. Let's run that again, and now it works. So we've retrieved all the records from the database without writing any SQL. We'll look at how to get individual records shortly, but first, let's move this code out of the controller. Basically, the only object we need to inject is the Entity Manager. So let's add the constructor method to this class, and as Doctrine provides an interface for the Entity Manager, we can add an argument to this method of the Entity Manager interface. Let's also import this class with a use statement. As we're type hinting to an interface, we need to tell the dependency injection container which class to create for this interface. So, in the Bootstrap script, let's add a new definition to the DI container for that interface. As this is going to be more than creating just a simple object, we need to define this as a function. And of course, this requires a use statement. Inside this function, we need to include this code from the product controller that initializes and configures Doctrine. So let's cut this from here and paste it in the DI container function. Let's also move these use statements from the controller to the Bootstrap file. Then, at the end of the function, instead of assigning the Entity Manager object to a variable, let's return it. Then, back in the product controller, we can now use the Entity Manager property that's been injected in the constructor. Let's try that, and it still works. So now, to get the records from the database, all we need to do is inject an Entity Manager object, get the repository for a particular entity from that, and call a method on the repository object. Let's see how we use this to get an individual record. At the top of the show method, let's get the repository from the Entity Manager property. Then, to get an individual record, instead of the findAll method, the find method will return a single object that matches the supplied ID. We're already getting the ID from the root argument, so we can pass that in. Then, in the call to the render method, let's pass the product object in instead of the ID. In the template for the show method, let's replace the contents of the h1 element with the name of the product, not forgetting to escape it. Likewise, let's replace the content of this paragraph element with the product description, and add another paragraph for the size. Before we try this, in the product index view, let's add an anchor tag around the product's name for each table row that links to the show page, including the product ID. Now on the products page, each product name is a link. If I click on these links, we're taken to the show page where the details of each product is shown. In the show method in the controller, instead of getting the repository first, then calling the find method on it, there's an alternative way of doing it. We can call the find method directly on the Entity Manager, passing in the entity class followed by the ID. And this gives the same results. There's a full list of available methods for retrieving data like this in the official documentation. Let's see how we can insert a new record using Doctrine by creating a page with a form where we can submit some data. So first, in the product controller, let's add a new public method called create. We'll need access to the request data in here, so let's include the request argument, and this will return a response. In the Bootstrap script, let's add a route that matches this method. We'll show the form and process it when it's submitted in the same method, so this route has to match both the get and post methods. Then, let's create a new file in the Views product folder called new.php. In here, let's extend the layout with a title of New Product, and add a heading followed by a form that uses the post method. Inside the form, let's add fields with associated labels for the name, description and size properties of a product. At the end, let's include a submit button. Then, back in the controller method, let's render this view. Before we try this, in the product index view, let's add a link to this page. So now on the product index page, there's the link, and clicking it takes us to the new product page. Up to now, we haven't really needed any styling, But, so this is clearer while we're developing, let's very quickly add some styling to this. When developing the backend, I recommend using a classless style sheet, as it adds styles without having to add any classes. Simple.css is an excellent example of this and is very easy to use. All we need to do is copy this link to the minified version of this framework and paste it in the layout view. Now the form has some basic styling. Note that as we added this to the layout file that's shared among all the view templates, they have also been affected by the styling. Now, back in the products controller, we can process the form when it's submitted. We'll handle this in the same method. To detect when the form is submitted, we can use the getMethod method on the request object. If this is equal to post, then the form was submitted. Then we need to get the data from the form. We can get this using the getParsedBody method on the request object. This will return an associative array of the data from the form, equivalent to the post superglobal. To save a new record using Doctrine, first we create a new product entity object. We can then use the setter methods on that object to set the properties, using the values from the form in the parameters array. Let's set the value of the name, description, and size properties. For the size parameter, the setSize method expects an integer argument. The values coming from the form in the parameters array will all be strings. So let's explicitly cast this value to an integer. For now, I'm just going to keep this simple and not add any validation. To save this entity to the database, first we need to call the persist method on the entity manager, passing in the object. This doesn't actually write anything to the database, it just tells the entity manager to be aware of this object. To write values to the database, we call the flush method. As we previously made the entity manager aware of the object that needed saving with the persist method, this line will actually commit the changes to the database. In this case, it will create a new record. In the database, as the ID column is an auto-increment integer, a value for this column will be assigned automatically. For now, let's get the ID from the product and print it out, then end the script. Let's try that, entering some data into the form and submitting it. We get an error, saying that the product entity is missing an assigned ID for the ID field. This is because we need to tell Doctrine that this column in the entity class will be generated by the database. We do that by adding a generated_value attribute. Let's try submitting the form again, and now we get the ID of the record that was inserted. If we look at all the records in the database, there's the new record with that ID. Instead of printing this out and exiting the script, once the new record has been added, let's redirect to the show page for that record. To redirect, we need to return a response with a location header. As redirecting like this is a common task, instead of doing that in here, let's add a method to do that to the abstract controller class. So let's add a protected method called redirect that has a string argument for the path, and this will return a response. Inside this method, as with the render method above, let's create a new response object with the factory. When we do this, let's assign a status code of 302. Then let's add a location header to this response, passing in the path, then at the end of the method return the response object. Then, back in the product controller, instead of this code, let's call the redirect method, passing in the URL path for the product show page, including the ID from the newly saved product. Let's give that a try. If I enter values into the form and submit it, we get redirected to the show page for that product. If we go to the products index page, we can see the two new records that we added. So, adding an ORM like Doctrine allows us to carry out actions that manipulate data in the database without having to write any SQL. Also, using entity classes gives us a clean, object-oriented way to work with database data instead of dealing with arrays. Thank you for watching, and I'll see you in the next one.